Picture stepping into a spacecraft and soaring to a distant alien world in mere hours, as effortlessly as boarding a plane to another continent. This is the thrilling vision of warp drives, made iconic by sci-fi epics like Star Trek, where the Enterprise zips through space at 9,000 times the speed of light, or Star Wars, where the Millennium Falcon rockets at millions of times that speed. These technologies shrink the vastness of the cosmos to something conquerable. But is this just Hollywood magic? Or could warp drives become reality? Science offers a surprising answer. It's not impossible. Let's explore the mind-bending science behind warp drives, the challenges we face, and the dreams they inspire, all in a way anyone can grasp. Our fastest spacecraft today, like NASA's Juno, travels at 74 kilometers per second, an incredible feat, yet a mere 0.002% of light speed, which is 792 kilometers per second. At that pace, reaching Proxima Centauri, our nearest stellar neighbor at 4.24 light-years away, would take about 20,000 years. A warp drive, though, could theoretically turn that journey into a day trip. The secret lies not in moving the spacecraft faster, but in reshaping the very fabric of space around it. The idea comes from Einstein's general relativity, which describes gravity as the bending of space-time, a kind of cosmic fabric weaving together space and time. In 1994, Mexican physicist Miguel Alcubierre, inspired by his love for Star Trek, proposed a radical concept. By tweaking Einstein's equations, he showed it's possible to create a warp bubble around a spacecraft. Inside this bubble, the ship sits still, while the space around it moves, carrying the craft along like a leaf on a river current. The bubble compresses space in front of the ship and expands it behind, allowing the ship to ride this wave of spacetime. This clever trick sidesteps the universal speed limit, the speed of light, because Einstein's rules only apply to objects moving through space, not to space itself moving. We see this in the universe already. During the Big Bang's rapid inflation, space expanded faster than light. Far-off galaxies at the universe's edge also appear to move away from us at superluminal speeds due to cosmic expansion. These examples prove spacetime can stretch and shift in ways that defy our everyday intuition. But here's the catch. Creating this warp bubble requires something called exotic matter, which has negative mass or negative energy, unlike regular matter or even antimatter, which has positive mass. Exotic matter would push things away rather than pull them in. Imagine a ball with negative mass. It would roll up a hill instead of down. The problem? We've never found exotic matter, and we don't know if it exists. Early calculations suggested you'd need negative energy equivalent to the mass of Jupiter to power a warp drive, an astronomical amount. Hope isn't lost, though. In 2011, physicist Harold White at NASA's EagleWorks laboratory redesigned the warp bubble into a more efficient donut shape, slashing the energy needs to roughly the mass of a small spacecraft. Then, in 2021, physicist Eric Lentz made a game-changing proposal, a warp drive powered by positive energy alone, using solitons, stable waves that could carry a ship through space like a gentle tide. These ideas are still theoretical, but they bring warp drives closer to possibility. Even if we solve the energy puzzle, challenges remain. The warp bubble needs an initial push to start moving, like a rocket needs fuel to launch. We're not sure how to provide that push without breaking physics. Then there's the danger of radiation as the bubble moves. It might collect particles and energy, releasing them in a destructive burst when it stops, potentially endangering the destination. Navigation is another hurdle. Inside the bubble, the ship is cut off from the outside universe. No signals, no visuals, no way to steer using conventional methods. Perhaps the strangest possibility is time travel. A 1996 study by physicist Alan Everett suggested that two warp bubbles moving in opposite directions could create a closed time-like curve, letting you travel back in time. This could lead to paradoxes, like preventing your own birth Some scientists think nature might have built-in safeguards, like quantum effects, to prevent such chaos. Despite these obstacles, warp drives are worth pursuing. They push the limits of physics, much like black holes did a century ago. Once just theoretical oddities in Einstein's math, black holes are now real. With images captured in 2019, warp drive research could spark similar breakthroughs, deepening our understanding of space-time and energy. Beyond science, warp drives challenge us to think bigger. What would it mean to reach other stars and ours? How would we navigate the ethics of exploring alien worlds? These questions make warp drives more than a gadget. They're a vision of humanity's future. Building a warp drive will take breakthroughs we can't yet imagine, from new energy sources to revolutionary materials. Yet the dream persists, fueled by scientists at NASA and beyond who refuse to accept the stars as out of reach. Warp drives embody our curiosity, our drive to explore, and our refusal to be bound by limits. One day, they might take us to the stars, not just in stories, but in reality.